Quantum Qubit Information Conspiracy by Francis T.S. Yu. My name is Anne Yu. I am the narrator for these slides by Professor Francis T.S. Yu. It is a pleasure for me to give this presentation of an interesting topic on qubit information conspiracy. Before I get started, I would like to make a couple remarks. First, a scientist's dilemma. Should we bury ourselves within a timeless, unrealizable science and thrive, or change to a physically realizable science in light? Second, as a learner, we gradually lose our independent logical thinking and opt to accept the approval of others. This slide shows a conventional information transmission through an additive Gaussian noisy channel, in which we see that an input information ensemble of A and an output information ensemble of B, respectively. This slide shows two key mutual information transmission equations for an additive Gaussian noisy channel as given respectively by first mutual information equation from A to B is equal to the input entropy of A minus conditional entropy of A over B, which is the information loss or equivocation due to noise. Second mutual information equation from A and B is equal to the output entropy of B minus conditional entropy of B over A, which is the noise entropy of the channel. This slide shows two key mutual information transmission equations for an additive Gaussian noisy channel as given respectively by first mutual information equation from A to B is equal to the input entropy of A minus conditional entropy of A over B, which is the information loss or equivocation due to noise. Second mutual information equation from A and B is equal to the output entropy of B minus conditional entropy of B over A, which is the noise entropy of the channel. However, there is a distinction between these mutual information equations. One is for information transmission and the other is for information retrieval. In other words, there are two kinds of communication orientations. One is for virtuous information retrieval of Norbert Wiener. The second is for reliable information transmission of Claude Shannon. Wiener's communication strategy essentially endeavors to recover information that has been corrupted through transmission. However, this strategy has a heavy price to pay because of the extensive post-processing involved at the receiving end. In contrast, Shannon's information transmission strategy does indeed carry an initial step by encoding the information before it is transmitted. In turn, the information can be more reliably received. This also has a price to pay, but mostly at the transmitting end. In summary, Wiener's strategy is to clean up the information at the receiving end. Shannon's strategy is to protect the information before it is sent. We can see that for reliable information transmission, it might be necessary to minimize the noise entropy or equivocation as shown by the following equation. Mutual information of A to B is approximated to input entropy H of A. One simple way to achieve this is by increasing the signal energy to noise ratio, in other words, delta E. And another is by redundancy coding. On the other hand, information retrieval is to maximize the noise entropy H of B over A, in other words, the channel noise, such that information from A to B approaches input entropy H of A as given by the following equation. Mutual information A to B equals to output entropy B minus channel noise entropy H of B over A, which is approximated to the input entropy H of A. This is because output entropy B is greater than input entropy. Since output entropy H of B is greater or equals to the input entropy H of A, we see that this is successful if and only if the channel entropy H of B over A is 0, which is equivalent to a lossless or noise-free channel. In view of quantum qubit information transmission, which is basically using Weiner's communication strategy, which necessitates a much higher price to pay at the receiving end, such as a longer section of time delta t is needed, and much more costlier. For example, a larger energy delta E is required, but moves further away from instantaneously transmitting. Since quantum qubit information transmission requires the receiving end entropy H of B to be more equivocal, in other words, uncertain, we see that it treats output entropy H of B as a source of entropy H of A. But without entropy H of B is greater than input entropy H of A, it does not mean that it increases output entropy HB at the receiving end and changes source entropy H of A at the transmitting end, since output entropy H of B can never be equal to input entropy H of A unless it is within a noiseless information channel. Nevertheless, a noiseless paradigm is not a physically realizable paradigm, since every transmission changes with time. In other words, a noiseless paradigm is a virtual, as mathematics is, which cannot exist within our temporal universe. T is greater than 0. This slide shows a quantum qubit information channel as depicted in the diagram. Since input information source of A is equal to 0, 1 is a binary digital source, we see that input entropy H of A equals to 1 bit per delta t. Why a section of time delta t is needed? Because every bit needs a section of delta t to represent a signal, no matter how small delta t is, but it cannot be equal to 0. In other words, delta t is equal to 0. And each section of delta t is a part of delta t, delta e, which is the necessary cost. Nevertheless, within an empty space, it has no time. My question is, how can we transmit a time signal without a section of delta t? We cannot. In view of the paradigm shown in this slide, we see that it is not a physically realizable paradigm, because empty space is not an accessible subspace within our temporal space by means of the temporal exclusive principle. Since within an empty space, every bit of information can be transmitted instantly because it has no time and no energy to pay, then input information source A is capable of transmitting a binary signal of 0 and 1 instantaneously and simultaneously without paying a price. We see that the instantaneous and simultaneous transmission of 0 and 1 is precisely what Schrödinger's fundamental principle of superposition stated. This is also the reason output entropy H of B has been treated as a qubit entropy by quantum scientists, since it appears that 0 and 1 are simultaneously existing, as given by the following equation. output entropy H of B equals to log base 2 of output ensemble P, in other words, probability distribution of qubit ensemble. Also, the following equation, output entropy equals to log base qubit of output probability ensemble in qubit unit. This slide shows a typical noiseless communications channel. For example, if one sent a 0 or a 1 message within an envelope to you, you would not know its contents until you opened the envelope. You would not know whether it's a binary yes or a binary no. I am stressing the fact that it's not your consciousness that changes the outcome of the sent message. Similarly, before you crack open a boiled egg, you do not know if the boiled egg is hard boiled or soft boiled. From this, we can see that it is not your consciousness again which changes the outcome. Let us talk about the legitimacy of quantum qubit information channel. From where, as I see it, quantum information transmission is basically designed to extract information as according to Weiner's communication strategy, which requires post-processing but with a bigger price to pay. Since it needs post-processing, the transmitted signal will deviate from instantaneous transmission, even though we assume qubit transmission works. Nevertheless, instantaneous transmission is not a physically realizable transmission. We see that qubit information is not a legitimately physically realizable information system, as in contrast to the temporal exclusive principle standpoint. In this slide, we will show that qubit information cannot be formulated within our temporal universe. Since within our temporal universe, t is greater than 0, everything has a price to pay. A section of time delta t and an amount of energy delta E for which every qubit needs a section of time delta t to transmit it, no matter how small it is. In other words, delta t approaches to 0. But never equals to 0. Otherwise, a qubit information cannot be formulated as a time signal within our temporal universe. T is greater than 0. In other words, without a section of time delta t to present a qubit information, there will be no qubit physical reality which can be transmitted within our time space, and as well within an empty space, since empty space has no time and no space. This slide shows a rectangular pulse time signal on the left and a wavelet time signal on the right, from which we can see that every signal needs a section of time delta t and an amount of energy delta E to represent a temporal signal. Nevertheless, aside serity of non-existent superposition principle, it must be the time signal representation within our temporal space, t is greater than 0, of which quantum qubit communication can only exist within an empty virtual space. But unfortunately, it cannot physically realize within our time space. In other words, qubit information is as virtual as mathematics is, which cannot be implemented within our temporal universe. Finally, let me hypothesize a noiseless communication scenario as shown in this slide, in which we assume a 1 message was inserted within an envelope sent through a noiseless, in other words, without contamination, channel to a receiver at B. Since the receiver does not know the message within the envelope until he opens it, which is similar to the half-life cat of Schrödinger until the observer opens Schrödinger's box, from which we see that the message within the envelope had been determined before it was sent, but it is not the receiver's consciousness that changes the outcome of the message. Similarly to the life of Schrödinger's cat, which had been determined before the observer opened Schrödinger's box. Moreover, we see that the transmission is not instant, since every bit takes a section of time delta t to transmit, and also an amount of energy delta E to make it happen, and thus it is not free. In conclusion, we have first shown that quantum qubit information transmission depends on Schrödinger's fundamental principle of superposition, but the principle cannot actually exist within our temporal universe of t is greater than 0. Secondly, we have shown that qubit quantum information is virtual, as is mathematics. It has no section of time to represent a time signal. In other words, qubit information only exists within an empty, timeless space of t is equal to 0, where the clock is not ticking. Qubit information does not exist within our universe, where the clock ticks on and on. From this, we see that qubit information is as elusive as Schrödinger's cat. And so we draw the conclusion that qubit information has become a worldwide qubit conspiracy, which is as fictitious as Schrödinger's half-life cat. Thank you.